Okay, so today we're going to learn about how to write the equations for a sequence. We have to write the explicit formula and the recursive formula. So what we're going to do first is we have to decide what type of sequence that you have, whether it's arithmetic, meaning that it's adding or subtracting, or if it's geometric, which means that it's multiplying, or sometimes dividing, which is the same as multiplying by a fraction. So let's check the first sequence that we have. If we double check -10 to -13, you could subtract 3, but you always check the second one, subtracting 3. So that means that this particular is arithmetic. So we have to remember that an arithmetic sequence, if you graph it, would look like a line, and an equation of a line is y equals mx plus b. So we've already figured out the slope, because the slope is the rate of change. Slope is the math word for change, and that's going to be -3. So our m is -3. But we have to figure out the y-intercept, and what we learned before is that the y-intercept is when it's next to the 0 or when it's the 0 term. So let's number our terms, 1, 2, 3, 4. To find the 0 term, we would have to go backwards. Now, if we're subtracting 3 to go this way, we would do the opposite and add 3 to go backwards. So let's add 3 to -10. -10 plus 3 is -7. So -7 is going to be your y-intercept. -7. And then you just write the equation y equals -3x, and then the -7 as your slope. Your y-intercept. Now at the bottom, we have to write the recursive formula, which is not that difficult as long as you've memorized the formula. You have to identify the first term. So the first term here is -10, not the 0 term, but the first term. And then you have to write the standard recursive form, which is f of n equals f of n minus 1, and then our slope, which is -3. So then we'll check the other sequence that we have. Is it arithmetic? Is it adding or subtracting? We don't know. Let's look. You could do 6 to 18 is plus 12, and then you check over here, but that's not plus 12, so let's try that again. This one seems to be multiplying by 3. That means that this sequence is geometric. And so the explicit form for a geometric sequence is different. It's not y equals mx plus b, because this will not be graphed as a line. Instead, we have to use y equals a b to the x, where a is your y-intercept and b is your ratio, or what you're changing by. So let's look at what we have. We have a ratio of 3, because it's right there, and we don't have our y-intercept yet. So let's number our terms real quick, like we did on the last one, because again we have to find the 0 term, because it's the 0 term that identifies our y-intercept. So if we're multiplying by 3 to go to the right, we would have to divide by 3 to go to the left. And if we divided by 3, we would get 2 to continue with the sequence. So that's our y-intercept. So now we put y equals, and the y-intercept is first, 2, and then the ratio, which is times 3, so we put a 3 is second, and you have that. That's all you have to do. Now the recursive formula is luckily the same as it is for an arithmetic sequence. You still have to identify the first term, which was 6 originally, and then you have to write the regular recursive form, f of n equals f of n minus 1, and this is not adding or subtracting, it's actually multiplying times 3. So there you go. Those are the 4 equations that you would have for these two sequences.